This is Note Taking Guide 2.8 for Math 3. We're talking about transformations today. So a transformation is moving a graph left, right, up, or down. So let's take a look and see what we're doing here today. So here's my original function over here on this side right here. And on this side, I ask you to take that function and I ask you to add 4 to this function. Now I want to make a point to you right here that we know that f of x represents a y value. So really what this asks me to do is to take my y values and add 4 to them. So what I'm going to do is I'm going to pick some spots on this graph and I'm just going to move them up 4 units and regraph them. So over here at 4, instead of crossing at 0, I'm going to cross up at 4. So here's my new spot on my graph. I'm going to do the same thing, just a few different spots on my graph so that I can get it graphed again in the right spot. And then again right here at -2, I would be up here at 4. I might want to grab some other ordered pairs the best that I can. Like here's this one at 0, 2. I would move it up to 0, 6. And then I would just do my best sketch of the graph through those ordered pairs, knowing that I changed it by adding 4 to my y values. So again, a +4 back behind means add 4. Alright, this time if you notice, the movement is on my x variable. It's not on my f of x variable, it's on my x variable. And x on a coordinate plane moves left and right. So I'm either moving this left or right. So how do we know which one? Well, I like to teach you guys to memorize it by doing the opposite of what it should be. So if this is +4, we're going -4. If we're talking about the x-axis and we want to move in the negative direction, that would be left. So we're actually going to move left 4 here. The other way that you can tell what you're going to do on this is to think about what the x value has to be in order to make that 0. The x would have to be -4 in order to make inside the parentheses there 0, which again tells me that I'm moving my graph to the left. So my original graph is here. I'm going to move it 4 units to the left. So instead of crossing at 4, 0, I'm going to move it 4 units to the left, which is right here. Instead of crossing there at 1, I'm going to move it 4 units to the left, and it's going to cross at -3. And instead of crossing here at -2, I'm going to move it 4 units to the left, and it's going to cross at -6. And then today, just because we're sketching, I'm going to sketch my graph through that real quickly. I'm not going to be super perfect, but it's just going to show me an approximate area of where my new graph would be. So again, if it's plus inside the parentheses here, that's going to be a movement to the left. Alright, so on this next graph here, then what do we think we're going to do with this 4 out front? If we notice that it's in front of the f of x and it's a multiply, it's really attached by multiplication. What are we going to do with our y values? Because this is an entire y value. It says multiply our y values by 4. So if I'm looking at this ordered pair right here, and this ordered pair is 4, 0, and I multiplied the y value by 4, I still am going to be at 4, 0. If I take this ordered pair, which is 1, 0, and I multiply it by 4 on the y value, I'm still going to be at 1, 0. So what's this graph going to change? Well, let's pick a couple of different ordered pairs and see what really happens there. So let's say we pick this one up here that's at 0, 2. Instead of being at 0, 2, when I multiply that by 4, I'm going to be at 0, 6. So my graph just jumped a whole lot going up vertically there. And then this one right here, it's not going to change where I'm at again just because of that y value. So what my new graph is going to do here like this is it's coming down like so. It really is kind of stretched vertically by multiplying that by 4. Alright, what do we think a negative out front's going to do? Again, that negative is multiplied by the y value, so it's going to flip my y values upside down. So this y value right here that is at 2 is going to become 0, -2, because I times it by a -1. This y value down here, if I were to pick, maybe that is the ordered pair 3 and then -2.5, it's going to be 3 and a +2.5, so it's going to be up here like this, up here somewhere. My other ones are still going to cross at the same spots because when I multiply my y values by 0, they're still going to stay 0. But instead of being the way the graph was right side up, it's kind of exactly the opposite or upside down. So a negative out front flips my graph the other direction. All right, so this says let's graph this and let's figure out what our real zeros are, our end behavior, and our y-intercept. If we know these things, we can graph anything. So I know I have x-intercepts at these values where my x's would make the parenthesis part 0. So I know that if I had x equals -3, that would cause this to be 0. So I would have a x-intercept there at -3. This is going to be an x-intercept at +1. So right here. And then this is going to be an x-intercept at x equals +4. So kind of right there somewhere. End behavior is where we take a look at our degree and the leading coefficient, and we decide if it's going up or down or up, or what the ends of my graph are going. I know this is going to be a power of 3 because x times x times x would be an x cubed. The signs out in front of those are all positive, a positive x, and a positive x, which would multiply to a positive x cubed. So because it's a power of 3 and it's positive out front, if you go back and you look at your end behavior chart, it's going to tell me that my graph should go like this. So I know I'm starting down like this, and I know I'm ending up like this. And then my y-intercept comes from setting x equal to 0. So when I set x equal to 0 here, I get 0 plus 3, which is 3, 0 minus 1, which is a -1, and 0 minus 4, which is a -4. When I multiply those all together, I get the value of 12. So I know I'm up here at 0, 12. I know that's not 12 up there, but I'm just going to kind of throw it up there, and my graph is going to come through like this for a quick sketch of what it's going to look like. So if I can find my zeros, my end behavior, and my x and y intercepts there, then I'm good to go with how to graph these. So here's another one. If we look at it this time, we know it's flipping upside down for end behavior. We know that we have 2 answers at x equals 4 because it's x equals 4 2 times, which means I have a multiplicity there, which means instead of crossing the graph like here would have crossed the graph, it's going to touch the graph and it's going to bounce back off. So it's going to bounce back off the graph at the point x equals 4. So 1, 2, 3, 4, I'm right here. We'll decide what our graph is doing right there, but I know it's bouncing. Then I'll have x equals -5 for another x-intercept. So right there somewhere. The end behavior, I know I'm negative, and I know I'm cubic, because a power of 2 here and a power of 1 here makes a power of 3. So cubic and negative means it starts up and it ends down. I know I'm bouncing off of this one, so I know I'm coming like this. So if I can find my y-intercept, then I'm good to go on this graph. So when I set x equal to 0 up here, I'd have -4 squared, which would be a +16 with a -16 thrown in front of it. And then I'd have 0 plus 5, which is just +5. I multiply that together and I get a hugely negative number. So all right, you guys, I'm not going to lie. Somebody just walked in on me and while I was recording, so I paused this video and I'm not sure where I left off. So now I'm just jumping to this one because I actually reworked the rest of this note-taking guide and forgot to hit record again. So I'm not sure where this ended up at. So let me just see if I can get you some help on these last ones, and if it is not enough information, you can come back and ask me some questions later. So this one says sketch the graph, and this time it's in polynomial form here, but it does say that one of my roots is -2. So what I'm going to do there is I'm going to take and do synthetic division with -2. So I'm going to go 1, 1, -22, and -40, and I'm going to do synthetic division. So I'm going to drop the 1 straight down, multiply by the -2, add straight down, multiply by the -2, add straight down, multiply by the -2, and add straight down. Once I'm to right here, you guys, I'm going to take this and I'm going to rewrite it out. So it'll be x squared minus x minus 20, and then I'm going to factor that. I didn't really leave myself any room to do this, so I'm kind of just on top of my graph, and I'm going to erase it in a minute. I'm looking for two numbers that will multiply to negative 20 and add to negative 1, which would be a negative 5 and a positive 4. So my real zeros are going to be the one that they gave me, x equals negative 2, and then the 2 that I just found. So x equals negative 4 and x equals positive 5, because these always come out as the opposites. All right, so I'm going to erase this now, and I'm going to graph what I have found out so far. So I know that I have x-intercepts at these points on my graph, and I'm going to just graph them there. I have x equals negative 2, I have x equals negative 4, and I have x equals positive 5. My end behavior comes from the leading coefficient and the degree. So the leading coefficient is 3. So, and the leading coefficient is a positive 1 and the degree is 3, which tells me if I look at my chart that my graph's going to end this direction and the other direction on the other side. Then the last thing I need to do is find the x-intercept. To find the x-intercept, I set x equal to 0, which means 0 cubed is 0, plus 0 squared, which is 0, minus 22 times 0, which is 0, and a minus 40. I'm just going to put minus 40 down here because my graph doesn't come that far, and I'm just going to sketch my graph according to those numbers that I have. Again, you guys, today it says sketch the graph, so we're not going to be perfect about it. If I wanted to find some exact points, then I could substitute in other x values into this equation up here and figure out some more exact values for that. All right, here's another one, same thing. They tell me here's the graph and here's one of my roots. So I'm going to put 1 over in the corner and do synthetic division. Leading coefficients are 1, negative 5, negative 8, and 12. And I'm going to drop down and do division. So 1 times 1 is 1. Add those straight down to get negative 4. Times by the corner to get negative 4. Add straight down to get negative 12. Multiply by the corner to get negative 12. Add straight down to get 0. So if when I rewrite this, x squared minus 4x minus 12, I'm looking for two numbers that will multiply to negative 12 and add to negative 4. Those two numbers that will do that are a negative 6 and a positive 2. They come out as their opposites. So two of my x-intercepts are negative 6 and negative 2. The third one is from up here. It's x equals 1. So 1, 2, 3, 4, 5, 6, which is here, negative 2, and positive 1. I can then look at my end behavior to see where my graph's starting and ending. It's a positive 3 as my degree and a positive 1 out front. So I'm going to start down over here and up over here. And if I substitute in 0 in order to find my y-intercept, it would be 0 minus 0 minus 0 plus 12. So that's off my graph again. But I would just come up here to a positive 12, sketch my graph through there, just something like that for my solution. All right, let's try another one and see how we're doing. Oh, we're actually done, I guess. You guys take a minute and pause the video right here and just make sure you get this copied down. But let me just explain to you what it's talking about. All graphs with degree 3 are going to have 3 complex solutions, meaning that the degree tells us how many solutions we're looking for. Some of them will be real and some of them will be not real. Our real solutions come from where our graph touches or crosses the x-axis. My graph touches 3 times right here, which means it has 3 real. And then I would have 0 non-real because they have to add up to be 3. Right here, though, where my graph touches only once, that means I have 1 real, but I have to have 3 solutions altogether because the degree is 3, which means I have 2 non-real solutions. And the same thing keeps happening. This is just a reminder that when I touch and bounce off the x-axis, that means more than 1 answer is there. So here's 2 real answers. Here's 1 for a total of 3 real answers. When you stop like this and kind of get a flat spot right there on the graph, which is happening right there, that means you have a multiplicity of 3. Your answer's happening 3 times right there. So you have 3 real solutions right there in that one spot. All right, the last thing does the exact same thing, but it's for degree 4, meaning that we should have 4 answers no matter what. So you look and see where it touches or crosses the x-axis. So 1, 2, 3, 4 times. There's 4 real solutions, 0 non-real because of the way that's happening. Again, if it gets a flat spot, it's a multiplicity of 3. If it bounces off, then it's a multiplicity of 2. And you can just figure those out from here. Just kind of a cheat sheet to help you figure out how many solutions you have when those things are happening. So pause the video, make sure you get this written down. Thanks for watching.